We have started to take a look at inheritance. We have created a child bank account that inherits from bank account, and we saw that it still has access to all of the public members that come from its parent. And we have also defined a new property and changed the definition of the constructor a little bit. But currently, it still behaves pretty much the same way. And the reason why we created a new class is because we want it to behave different. Even when it's still a bank account and it will behave very similar, it should have its own functionality. And so what we can think about is implementing the add balance method in a different way. Maybe the child bank account cannot subtract more than $10 from the balance because it's the children we're talking about. So how do we make this evaluation? Do we create another add balance method inside of the child bank account? Well, sort of. What we're going to take a look is overriding. An overriding is being able to use a method that exists on the parent and add some functionality to that method, or entirely change it. To be able to override a method, we first need to change its definition a little bit. We're going to be defining the methods that we want to allow overriding for as virtual. And so we want to define both add balance methods as virtual. What virtual allows us to do is go back to any one of the classes that are inheriting from this class, write override, write space, and see that these two methods now appear able to be overridden. Just in case you're wondering about the equals, the get hashcode, and the toString methods, these are methods that come directly from the object class. It turns out that every single class inherits from the object class, even if it's not defined. By default, every class would act as if it had this in this definition. Whether it has it or not, every class is going to be inheriting from object. And so those three methods come directly from that type. But what we want to do is override the add balance methods. And the first one that we are going to override is the one that only receives one value. And notice that as soon as we override it, it's going to do the same thing as its base method. The base again refers to the base class, in this case, the parent class, the bank account. And it's calling the add balance method, and it's passing the balance to be added. By the way, I have a typo in here. So as soon as we override this add balance method, it's going to behave the exact same way as the method in the base class, because it's actually calling that method to do its work. But what we want to do is first evaluate if the balance to be added is not less than -10. We said that maybe the child bank account cannot subtract more than $10 from the balance. So before calling the base method, let's add an evaluation. If the balance to be added is greater or equal to -10, then we can perform this evaluation. If not, we're just going to return the current balance. And notice that we do have access to the balance property even when it is not defined inside of this class, because it is being inherited directly from the parent class. And so we have changed how the first add balance method works inside of the child bank account. In case the balance to be added is less than 10, it's not going to perform any evaluation, it's just going to return the current balance. In case it is -10 or above, it is going to go ahead and do whatever the base method does, which in this case is just add that balance to the current balance and return it. Now let's override the other add balance method that we have. Again, all we have to do is write override, find the method that we want to override, and type enter. Again, by default, the functionality is going to be the same as the base method because it's actually being called and nothing else has been added. But what we want to do is add the exact same evaluation. If the balance to be added is greater or equal to -10, then we can go ahead and perform the evaluation. If it is not, it's just going to be returning the balance again. So in this case, the overload of the add balance method is still going to be doing the same, but it's first going to evaluate if the balance to be added is greater or equal than -10. So for example, the balance to be added can be minus 10, and the balance can be negative can still be true. So for example, if the balance was 9 and the balance to be added was minus 10, the result would be minus 1. And if balance can be negative is set to true, that minus 1 can still be set to the balance. But if balance to be added is, for example, minus 11, what will happen is just that the balance is going to be returned. No operation is going to be executed. Or that is what we want to happen. Let's take a look at if it is actually happening. We don't really need to change anything because now the add balance that is being used from the child bank account now refers to the add balance method that is defined inside of the child bank account. So if we run this on the console, we see that the balance is no longer minus 100. It's still the initial balance, which is 1321, because the balance that we want to add is less than minus 10, way less than minus 10. So it's not being executed. All it does is return the value inside of the balance. And this is how you override methods. You first have to define them as virtual, and then on the child class, the class that is inheriting from that class, we have to override them, and then we can still call the base method, so it performs what the base method does, but add our own code. In this case, we're making some evaluations before calling that base method. In the next lecture, we're going to take a look at something that may look very similar to classes and in fact inheritance, and that is interfaces and how to implement them.